My dear students, welcome to this session, the fundamental of IoT and the embedded system. In this topic, we can discuss about the exploring the fundamental technologies that power our connected world, from the tiny sensor to complex embedded system that make the Internet of Things is more possible with us. What is the Internet of Things? That means IoT is a network of interconnected physical devices embedded with the sensor software and connectivity which enable them to collect and exchange the data sensitively. From a smart thermostat to industry machinery, billions of devices communicate automatically to engage our daily lives and business. IoT framework, we have the main component, device layer, and then connectivity layer, data processing, and then application layer. Device layer is commonly known as the physical sensor and actuator that interact with the real world, collecting data and performing the actions. Communication protocol like a Wi-Fi, Bluetooth, cellular, and LAN, then that enable the device to device and the device to cloud communications. Data processing means the cloud performs an edge computing system that analyzes, store, and process the massive amount of IoT data. Application layer is the final layer, user interface, dashboard, and application that present insight and enable the control of IoT systems. Key of IoT technologies: microcontroller process, wireless communication, power management. The three is a major enabled technology of IoT. Now discuss about the implement of IoT. A complete procedure we can discuss. First, you know the requirement analysis, then hardware selection. After that, connectivity design, software development, final testing, and deployment. The 5 steps we need to implement the IoT well and good. Next, we understand what is the embedded system. Embedded system is a specialized computer system designed to perform delicate function within the layer of mechanical and electronic systems. Unlike general purpose of computer, they are organized for specific tasks with a constraint on power, size, and cost while maintaining the high reliability. There's a real-time operation capabilities, resource constrained environment, application-specific functionality, and then we discuss about this single-chip microcontroller system. It have architecture and then application. Complete computer system and single integrated circuit it is include central process unit and memory and also input output devices. It have inbuilt with the program memory is a flash type, data memory is a RAM type, built-in timer and counters. This should be applied the home appliance controller, automotive sensor, basic IoT devices. Single board system microcontroller plus computer. We need to understand what is the difference between the microcontroller and the computer in the single board system. Single board microcontroller is example for Arduino ESP32. It is a single program environment, real-time operations, lower power consumption, limited processing power. Definitely, single board computer is a Raspberry Pi and then backbone system. It's a fully operating system support, high processing capabilities, multiple communication interface, greater power requirement. And then we discuss how the essential embedded system in our day-to-day activities. IO in and output interfaces, timer and counter, analog and digital converters, interrupt controller. It's mainly focus the input or output interface, G pin, UART and SPI and 12C protocol enable communication with sensor, display, and other devices for data exchange and control. It gives some timer and controller. Hardware timer provide precise time control for PWM generation, event scheduling, real-time operation, embedded applications. Analog to digital converter as well as digital to analog converter bridge the gap between the analog and the digital sensor and an interpret controller that manages synchronized event and enable the responsive system behavior by handling external signal and internal system event efficiently. Next we discuss about the software considered for embedded system. Because the embedded system it have the real-time operating system and we need some memory management and then power optimizations. Real-time operating system means it ensures determine the response time and efficient task scheduling for critical applications. Optimize RAM and flash usage through the efficient algorithm and careful resource allocation methods. Power optimization is a main requirement because the dynamic and static frequency scaling and efficient code and extend the battery life to a long-time battery management system required the power optimization method. I hope students you have understand what is the embedded system as well as the uh, fundamental of IoT. Thanks for listening this video. If you have any doubt, kindly ask me in the comment box. Thank you.